Okay, this is where it starts to get fun. I like this part. Hopefully some of you guys will like this too. Have you ever seen Pascal's triangle before? I really like Pascal's triangle for a lot of reasons. For one, it's just a fun math puzzle, and I like fun math puzzles, and I think some of you guys like fun math puzzles as well. In addition, people are always asking the question, when am I ever going to have to use this? And I actually like that question a lot. But sometimes in math, just like in science, just like in a lot of other areas, we find things and we don't know what their use is. And then later on, someone goes, oh my gosh, did you see this? It matches with this other thing that they talked about. And so, for instance, Pascal, he came up with this pattern. He noticed this pattern and he put it into this form of a triangle. And at the time, I'm sure people said, well, that's nice, Blaze, but what are you going to do with that triangle? And at the time, there might not have been an answer. But the cool thing is, later on, people realized how many implications there are for Pascal's triangle. And so we're going to look at some of those implications today in this video. But what I want you to do is take a minute to pause the video, and can you look at the patterns that are occurring here? And can you fill out the bottom two rows, which right now are just gray boxes? Are you able to fill those out? And do you know what the patterns are that are occurring? Basically, the idea would be that you could just fill out this triangle indefinitely. If I asked you what is row 21, you could fill it out and you would know what row 21 is. Okay, pause the video here. See what you can do on this triangle. See if you can find some of the patterns. Okay, as you look at what I have written in here, do you have these same numbers written in as I do? Make sure you are aware of what the numbers are supposed to be. So look at those numbers and check yours. Some of the patterns. Okay, some things that people say. They say, well, I noticed that going down this way, they're all ones. And the same thing over here, they're all ones. And then you go 1, 2, 3, 4, 5, 6, 7, and same thing here. And then it starts to get a little bit more confusing. Well, some people say, well, look, we add 2, and then we add 3, and then we add 4, and then we add 5, and then we add 6. And here we add 3, 5, 10. That's not much of a pattern, is it? 15. So there are a lot of different ways that you can look at this. But the way I'm going to emphasize is that what you do is you add the two numbers up above to come up with the number down below. So 1 plus 3 is 4, 3 plus 3 is 6, and so forth. So down here, 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, and so forth. And so that's how you come up with Pascal's triangle. We in this class are going to use this quite a bit. And probably the most common ones that we're going to use are rows 3, 4, and 5. Now, we could go above and beyond that and down to 6 and 7 and so forth, but we're really going to focus on rows 3, 4, and 5. And I'm going to say that you need to memorize Pascal's triangle. You don't have to memorize, all you have to know is that you add the 2 above it to come up with that one. But basically, this is one of those things that when you come up to a test, you need to be able to think in your head and just go out into the margin and start creating Pascal's triangle out in the margin. So make sure you understand Pascal's triangle and how it works, because we're about to find out what one of those uses are for Pascal's triangle. If you turn the page, I have set up here what I'm trying to help you understand how Pascal's triangle works. So you know that anything to the 0 power is what? What is anything to the 0 power? Well, it's just 1. I'm going to put my 1 out here kind of in the middle. Anything to the first power is just itself. And so x plus y to the first is just x plus y. Now I intentionally wrote in my 1s with it. What is x plus y to the second? You might have memorized the pattern for this because this is a perfect square pattern, and I did present that to you, and that is an option to memorize it, or you just need to know how to multiply it out. Either way, you come up with 1x squared plus 2xy plus 1y squared. Okay, well, what is x plus y to the third? Well, x plus y to the third, we would have to multiply by another x plus y. Or in other words, take this and multiply it by x plus y. So let's go ahead and do that. When we multiply this all the way out, I'm going to take a second to multiply this all the way out. Okay, so if you look over here in the margin, I multiplied this all the way out I was double distributing. And this is, again, one thing where some people like to use the box method. You could certainly use the box method. I didn't draw all my lines in because it starts to get kind of messy, but I'm just multiplying these two by distributing. When I do that, I get all of these terms, but then they do combine down to where their like terms are written here. I'm going to put that up here in my what's becoming a triangle. If you didn't like that was long and confusing and a lot of work, then I have good news for you. And the good news is you don't really have to do that anymore, because really this is part of Pascal's triangle. So if we look at Pascal's triangle and we notice what's going on. Okay, if I think about what Pascal's triangle looks like, and I can reproduce it over here in the margin if I'm taking a test or a quiz, look what I have. My leading coefficients are all matching up with what I have here. And so this one that's in blue, 1, 3, 3, 1, that's right here in the fourth row of the triangle, 1, 3, 3, 1. And so for my next one, I don't have to multiply this out again, because wouldn't that take forever if I had to do that? Instead, this is what I'm going to do. I'm going to write, and so right now, if you're not sure where I am in the triangle, I am right here on this 1, 4, 6, 4, 1 row. And I'm going to write this out 1, 4, 6, 4, 1. I'm going to give myself some space. 1, 4, I'm going to skip some space, 6, 4, 1. I could have skipped more space, but anyway, that's what I have. Now, can you look at what's going on and see the patterns that are going on? And so maybe before we fill out this green line, let's take a look at what are some of the patterns. Take a second to look at this. And do you know what these patterns are? Can you list out some of them? Take a minute to look at this and see what you come up with. If we're talking about x plus y to the nth power, what are some of the patterns? Pause the video here and write down some information. Okay, here are some things I want you to notice. The number of terms, in other words, this has one term, this has two terms, this has three terms, four terms, etc. So the number of terms, I should rewrite this, is actually n plus 1. That is, if it's a first power, there are two terms. If it's a third power, there are four terms. Look how the exponents go. The exponents start at x to the nth power and go all the way down to x to the 0 power. So let's look at this blue line as our example here, our third power. X to the third, because it's a third power. X to the third, x to the second, x, no x. The y's go the other way. They start at y to the 0 and they go up to y to the nth power. Again, let's look at our blue line. Y to the 0, y to the 1, y to the second, y to the third. Our first term is always 1x to the nth power, 1x to the third, because it's the third, 1x to the second, because it's the second, and so forth. Our last term is always 1y to the nth power. So if this is y to the second, we go over to our last term, y to the second. This one's y to the third, last term, y to the third. Our first term is always 1x to the whatever. Our second term starts with whatever exponent. So like this x to the third right here starts with the 3 goes in that second term. And then the n is 1 down from that, and then that's when the y starts at that point. The coefficient of the second term is n. That's the coefficient. The number in front of it is called the coefficient. And then the sum of the exponents is n. In other words, third power plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. 3 plus 0 is 3. Okay, with that information, we can fill in what I have here in green. So the first term is going to be 1x to the fourth. Our second term is going to be 4 and then x to the third y, because now the y's start in. The next term, I went 4, 3, I'm down to 2x squared, y squared, because it was going up, y0, y1, y2. Now I have x to the first, y to the third. And now my x is gone, and I am up to y to the fourth. Let's take a minute to look. My x exponents: x to the fourth, x to the third, x to the second, x to the first, no x. My y's: no y, y to the first, y to the second, y to the third, y to the fourth. And then I check it by adding my exponents. This adds up to 4. 3 plus 1 adds up to 4. 2 plus 2 adds up to 4. 3 plus 1 adds up to 4, and 4. So that is the expansion for x plus y to the fourth power. I don't have to do all this multiply, 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 multiply like we did before in the margin. I'm able to just fill in the pattern from here. We're going to use these patterns and figure out how to multiply binomials in this method. Okay, so let's look at our first example here. First of all, out in the margin, let's call them x and y. So x is 5, x is x, and this time y is 5, right? It's not y, it's a 5. And so it's a 3, so I go to my triangle and I go to my third row, and this time I'm not going to be using that one I had there a second ago. I'm going to be using the 1, 3, 3, 1. That's the one that goes with the 3's. So I'm going to come down here and I'm going to do 1, 3, 3, 1. I'm going to give myself some space. 1, 3, 3, 1. Okay. 1, x to the third, but no 5. Doesn't go in there. 3, x squared. You know what? Let me just do the x's at first. X to the third, x to the second, x, no x. With the 5's, no 5 on the first one. The next one is going to get a 5. The next one's going to get 5 to the second. And the third, or the last one's going to get 5 to the third. Let's check our powers. Adds up to 3, adds up to 3, adds up to 3, adds to 3. Now I'm going to simplify. I don't really need that 1, right? When I write my answer, I can just write x to the third. 3 times 5 is 15. This time, 5 squared is 25 times 3 is 75. And 5 to the third is 125. So that is my final answer. So if we know Pascal's triangle and we know the patterns, we can use that to identify these answers without multiplying out, multiplying out, multiplying out, multiplying out. Let's take a look at this next one because we now have a little bit more complex numbers. Because here our x is actually 2x and our y is 3. And we have a fourth power. So on our triangle, we're going back to what I have highlighted in yellow here, the 1, 4, 6, 4, 1. So I'm going to give myself some space. 1, 4, 6, 4, 1. I might not have given myself enough space. Let's see. The variable that's supposed to go here is a fourth power, and it's 2x. So it's 2x to the fourth. All right, I didn't give myself enough space, so I had to stick in a little plus there. The next one is going to be 2x to the third, and then 2x squared, and then 2x, and then no 2x on this one. Going to go to my y's, which is a 3. I don't need one on the first one. My next one, I need a 3 to the first, and I need a plus in here. Okay, on this term, I'm going to need a 3 to the second, and I'm going to put in my plus, and here I need a 3 to the third, and I need my plus, and then I need a 3 to the fourth. Let's double check. 2x to the fourth, 2x to the third, 2x to the second, 2x, no 2x. No 3, 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. Check our powers. Fourth power, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, fourth power. Notice when I plug them in, I put them in parentheses because everything has to be cubed or whatever. You have to multiply it all the way in. So 2 to the fourth, do you know what 2 to the fourth is? 16. So my first term is 16x to the fourth because 2 to the fourth is 16. And then I have a 4 and an 8x to the third and a 3. I'm going to take a couple steps to simplify mine. Some of you can just simplify it all in one step. That's great. I'm going to take a couple steps. The next one, I have a 6, and I have a 4x squared, and I have a 9. Then I have a 4, and now this one I'm going to go ahead and multiply because I can do that. 4 times 2 is 8, so I have an 8x and a 27. And then I have 3 to the 4th. That's 81. So in the end, I have 16x to the 4th plus 96x to the 3rd plus 216x squared plus 216x plus 81. Now, a lot of that you might need a calculator for, so have a calculator handy so you're able to do that. Okay, I want you to pause the video here, and I want you to try to set this one up. I'm going to give you a head start by telling you that x is 3x and y is negative 2y. And then from there, you should be able to set up your pattern and plug these in and see what you get. Pause the video here and see what you can do. Okay, take a minute to look and see, do you have this answer? If you didn't come up with this answer, then go back because I showed my middle step here of what I multiplied. A couple things to notice. Again, when I plugged in that negative 2y, I plugged it in parentheses, so I made sure when I squared it, for instance, I had my signs right. Or if I cubed it, I have my signs right. So some of these have minus signs in the answer, whereas the other ones have plus signs in the answer, depending on how many 2y's are there. So again, just double check, look at that middle row, make sure you came up with everything right. We will work on this tomorrow, and I'm sure there will be questions, so we'll continue to work on this tomorrow. Take a minute right now to write in some things in the summary. There are lots of things that you could write in here. In addition, something else you could do is take a minute right now to write down some questions in the margins. So I've just done a bunch of stuff, and maybe you didn't understand some of it. So you know that tomorrow in class we're going to discuss this. I'm going to ask you to talk in your groups about questions. So write down in the margins some questions you have. How did she come up with that? Where did this number come from? Whatever. So go ahead and fill in margins and fill in summary. And like I said, we will work on this more tomorrow.